Hey everyone, welcome to The Explainer. Today, we are looking at something that is literally hiding in plain sight, probably sitting right there on your desk. Okay, let's dive into this. We are going to explore the ruler's secret, and while we're at it, we'll completely re-examine the underlying mechanics of fractions. It's going to be a lot of fun.
So check out this toy monkey. It's missing an arm, right? Well, it's actually a pretty perfect metaphor for a really fundamental question. What happens when a whole is broken into parts? You know, a complete object is super easy to count. Boom, that's one whole. But when the physical world doesn't line up perfectly with those neat whole numbers, well, we have to invent ways to measure the fragmented and the partial.
Which brings us to Section 1, Parts of a Whole.
Let's look at the fraction 1/10. Now, I want you to think of this not just as a random number, but as a foundational puzzle piece. If you take literally any whole object and slice it equally into 10 exact pieces, you get this standard building block. And it's absolutely crucial for constructing a much deeper understanding of measurement.
And this brilliantly illustrates exactly what 1/10 looks like in reality. Notice those little markings between the 0 and the 1 centimeter line? There are 10 tiny, equally spaced ticks there. Because exactly 10 millimeters packed tightly inside one whole centimeter, a single millimeter is exactly 1/10 of a centimeter. We've basically taken an abstract math concept and slapped it right onto physical space.
All right, moving on to Section 2, Measuring Everyday Objects.
Imagine grabbing a standard piece of chalk. If you were to place it against a ruler right now, how long do you think it is? Does it just hit that 1 centimeter line perfectly? Think about it for a second.
Well, here's the reality. Notice how the chalk goes past the 1 centimeter mark, but it definitely stops short of the 2. It lands exactly on the 4th millimeter line. So to accurately describe this, we need to use those fractional puzzle pieces we talked about. It's 1 whole centimeter plus 4/10 of the next one. And the eraser and the pencil, they behave the exact same way. Everyday items rarely land perfectly on a whole number, so they literally demand fractions to tell their true story.
That leads us to Section 3, Understanding Mixed Numbers.
Now, what's really interesting about this slide is how clearly it highlights variation using just everyday hardware. We've got these different screws, and they all start at the 0 mark. But notice how absolutely none of them land perfectly on a solid centimeter line. One screw goes just a little past the 3, while another pushes almost all the way to the 4. So we can literally see the mixed numbers right here, the whole centimeters combined with the fractional millimeters extending out perfectly.
So, translating what we just saw into formal data gives us mixed numbers. Screw A measures exactly 4 3/10 centimeters. Screw B is 5 8/10, and screw C comes in at 8 4/10. This is how we standardize messy, real-world measurements into precise, actionable data that anyone can understand.
Which brings us to our final section, Section 4, Putting it all together.
Let's move to and see how this builds. Imagine you're combining two lengths, 2 7/10 plus 3 6/10. We're going to tackle this methodically. Step 1, just add the whole numbers together to get 5. Step 2, combine the numerators, that top number, so 7 plus 6 yields 13. Step 3, keep the denominator exactly the same, so we get a preliminary result of 5 13/10.
But here's the catch. 5 13/10 is an improper fraction, right? It's kind of top-heavy, because 10 of those tenths form a brand new whole number. So the crucial point is the conversion. Step 1, convert 13/10 into one whole with 3/10 left over. Step 2, add that newly formed 1 right onto our 5. And Step 3, tack on the remaining 3/10. That gives us a mathematically clean final answer of 6 3/10.
You know, mathematics is absolutely brilliant because there's almost always more than one valid path to the answer. On one hand, we have method A, which is the step-by-step mixed number route we just did. On the other hand is method B, breaking everything down into base tenths from the very start. So 2 7/10 is simply 27/10. 3 6/10 is 36/10. Add those up for 63/10 total, which converts right back to 6 3/10. It's the exact same mathematical truth, just taking a slightly different operational route. As we wrap up this explainer, I want you to consider this. Every big thing in the world can be measured by looking at its smallest parts. By really mastering the fractional components, those tiny tenths and millimeters, we gain the immense power to accurately describe and calculate the larger whole. We literally take the fragments and we mathematically make them whole again. How cool is that?
If you can understand the millimeter, you can measure the world.
So, what will you measure next? I really want you to think about that question the next time you pick up a ruler or look at a seemingly broken piece of a whole. The mathematical tools are entirely in your hands now. Thanks so much for learning with me today, and I'll catch you in the next explainer.